Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will start learning about the lighting systems and its manual designing steps. So fasten your belt and let's get started. The aim of this tutorial is to start learning how to design any lighting system. So we need to know what are the different steps of designing the lighting system, as we will start constructing the lighting systems using the manual calculations. So let's go ahead. First of all, we need to say that for the manual lighting system design, there are some manual steps we use for designing any lighting system. And the first step of them is to detect the total number of luminaires required for any place. So if we have a room and we need to make a lighting system for that room, the first thing we will do is to calculate the total number of luminaires which we will use in that room. Also, the second step is to detect the shape of the luminaires distribution. This is because if we decided that we need, for example, 6 luminaires, this will not be enough, as the number of luminaires can have different shapes of distribution across the ceiling of the room. So one distribution strategy is to spread the luminaires along the width of the ceiling. So if the luminaires are put across the width of the ceiling, this will be one strategy of distribution. Also, another strategy of distribution is to spread the 6 luminaires across the length of the ceiling. So we can spread across the length and we can spread across the width for the same number of luminaires. And there may be some other methods of distribution of the luminaires, but anyway, those are the steps of designing, which are to detect the number of luminaires and then to select the suitable way of distributing them. Alright, now we need to know in some details how can we calculate the suitable number of luminaires required for any room. Here we say that the required number of luminaires is calculated from this equation. Here n equals E times A over phi times LLF times UF. As you see, n is the number of luminaires required for that room, so it's the final aim that we need to reach, which are the required number of luminaires. And then in the numerator we have E times A, where E is the value of the illumination or lux required for that place or that room. If you remember, we learned it before that the illumination or the lux is the amount of light that we will supply the room with. And this amount of light that the room will need depends on the type of the room itself, as each type of room will need a specific amount of lux according to the nature of the room itself or the application that we need the room for. For example, some rooms will need a larger amount of lux or it needs higher illumination. This is because the type of the application that we will use the room for needs larger lumens, like the reading room, as it needs larger lux for reading. On the other hand, some other rooms need smaller amount of illumination or lux, like the sleeping room, as it needs to be more calm or to have more relaxation, so its amount of lux will be smaller. And we detect this value of lux from some codes, which may be an international standard code or it may be a national code like your country code. And this is an example of the required amount of lux needed for some different rooms according to their type. You can see the living room needs 50 lux, and for example for the bedroom it needs 150 lux, and also for the bathroom it needs 100 lux. So according to the room type we detect the lux. Very good. Now the second factor in this equation is A, and A is the room area simply. So to detect the number of luminaires we multiply the lux of the room by the room area. And the room area equals the room length times the room width. So we must know what is the area of the room to detect the required number of luminaires. Alright, that's for the numerator. Now for the denominator, the first parameter we have is phi, or the flux, which we illustrated before. Here phi is the luminous flux of the luminaire, and it depends on the amount of light that is going out of the luminaire itself, so it depends on the luminaire. As it's the lamp light intensity, so it's the intensity of the light out of the lamp. And we detect this value from the datasheet of the lamp. So once we decide that this type of lamp, or we will use that type of luminaire, we open its datasheet and we detect the luminous flux from it. For example, this LED lamp has a rated luminous flux of 600, so we will substitute with 600 in this equation, or we will substitute with 600 instead of phi. Very good. Now the next factor we have is LLF, and LLF is the light loss factor, or the maintenance factor, and this factor is used to detect the losses in the light out of the luminaire, as there will be some losses in the light, so we need to put those losses in consideration to compensate those losses. And to detect this factor LLF, we find it to be the multiplication of 6 other factors. Here LLF equal LLD times LDD times LDF times RSDE times LPO times VVF. But we need now to know what is each of those 6 factors. Here, the first factor of them is LLD, or the lamp lumens depreciation, and it refers to the performance of the lamp, or the lumens out of it across its life. This is because the lamp's performance changes when its time passes, or the number of lumens out of the lamp is not a constant one across its time, but the lumens of the lamp decreases across its life. And this factor LLD equals the mean lumens over the rated lumens. So we calculate the average lumens compared to the rated lumens that the luminaire is designed to produce. And this value LDD is detected also from the lamp datasheet, so it depends on the luminaire type itself. Very good. Now the second factor we have is LDD, and LDD is the luminaire dirt depreciation, and it measures the amount of lumens that is lost due to the dirt of the luminaire surface. This is because when dirts or dust are accumulated on the luminaire surface, the output lumens will decrease. Hence, we need to consider this decrease in the lumens output of the luminaire due to the dirt effect. Alright. Now the third factor we have is LDF, and LDF is a factor that measures the amount of lumens that is lost due to the dirt of the lamp surface. This is because when the dirt or the dust are accumulated on the lamp surface, the output lumens will decrease of the lamp. Hence, we need to consider this decrease of the lumens output of the lamp due to the dirt effect. But you can notice here that we are considering now the dirt on the lamp itself, while for the previous factor it was for the dirt on the luminaire, not the lamp, as it was the luminaire dirt depreciation. And this is because the luminaire consists of some lamps, and each lamp of them has a surface, and the luminaire itself has another surface, which is the luminaire cover. So we take the luminaire surface and the lamp surface in consideration. So we take both of the luminaire surface and the lamp surface in consideration to measure the amount of dirt or the amount of dust on them. Alright. Now the fourth factor we have is RSDD, and RSDD is the room surface dirt depreciation. And this factor is related to the dirt on the surface of the room, as when the room surfaces has dirt on it or has dust on it, this will absorb the lumens out of the lamp and decrease the effect of the light out of the lamp. While when the room surfaces have less dust or less dirt, this increases the effect of the light or illumination, which makes the room to appear more bright. So that's for RSDD. Now the fifth factor we have is LPO, or lamp burn out, and this factor considers the case at which we have some lamps which are burned out of the luminaire. So the ideal case is to have all the lamps on the luminaire to be working, but we suppose the worst case at which there may be some burned out lamps, so the total output lumens of the luminaire will decrease, and for that reason we must increase the total number of lumens to compensate this decrease in the output light due to the burned out lamps. Very good. Now we have the final factor, which is VVF, or the voltage variation factor. And this factor considers that there is some losses in the output light due to the variation of the input voltage. As we know, the lamp input power is the voltage times the current, and its output power is the light out of the lamp. So if the input voltage of the lamp decreases, the output light of the lamp will decrease greatly. And this is because each 1% decrease in the input voltage results in 3% decrease in the output light. So it has a larger effect of decreasing the output light, which is about 3 times the decrease of the input voltage. And for that reason, the voltage is an important factor which we must conserve to have a constant value, not to affect the output lighting system or the output lumens. Alright. Now, after discussing those 6 factors of the LLF, we need to know practically how can we set the value of LLF. As in the practical working, LLF is set with an approximate value according to the case we are working on, and this depends on the maintenance of the luminaire. As in case of there is an irregular maintenance of the luminaire, we will set the LLF with a value that ranges from 0.6 till 0.75. And this means that the luminaire is not checked and maintained regularly. While if there is a regular maintenance of the luminaire, we will set LLF with a value that ranges from 0.7 till 0.9. So this is in case of the irregular maintenance. But you can ask now, how can we set LLF in case of we don't know how the future maintenance will be? So we don't know if the future maintenance is a regular maintenance or an irregular maintenance. Here at that case we will put LLF with 0.8, that is a middle value or an approximate one. So LLF is used practically with 0.8 in case of the unknown case of the maintenance. More than great. So that's about this tutorial at which we started explaining the lighting manual designing steps, and on the next tutorial we will continue illustrating this topic. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will continue talking about the lighting system and its manual designing steps. So fasten your belt and let's get started. The aim of this tutorial is to continue learning how to design any lighting system, so we need to continue learning about the different steps of designing the lighting system, as we will continue constructing the lighting systems using the manual calculations. So let's go ahead. If you remember, in the previous tutorial we illustrated the first 4 parameters required for calculating the required number of luminaires for any room which we are making the design for, and those 4 parameters are the lux required for the room, the area of the room, the lumens out of the luminaire, and the light loss factor of the luminaires we have. And now the final factor we have to discuss is the utilization factor, or UF. So we need to know what the utilization factor is. Here we say that the utilization factor is a factor which specifies the percentage of the E-comfort when using the lighting system. This is because not all the lighting systems have the same E-comfort. For example, when you exist in a room, you can feel very comfort. This is because your eyes can feel this comfort of the lighting system. On the other hand, you can exist in another room where you doesn't feel any comfort or the lighting system annoys you very much. And this is because the percentage of the E-comfort in this room is low. So what we wanted to say is that when we have a higher utilization factor of the lighting system at the room, this means that the E-comfort in that room is high, And the inverse is right, as when we have lower utilization factor of the room, this means that the e-comfort of that room is low. And for that reason, we must take the utilization factor in consideration when designing the lighting system for any place to have the sufficient degree of the e-comfort. And this utilization factor is a percentage which is less than 1 at all cases. So if its value is 1, this means that we have the ideal system 100%, but actually any lighting system is not an ideal one 100%, so it's a ratio which is less than 1. And for that reason, the utilization factor must be higher than 0.4 to have a good e-comfort. So if its value is less than 0.4, this means that there is no e-comfort in the lighting system, so we make our design to have a utilization factor which is higher than 0.4. And also, as we said, when this ratio increases, the e-comfort increases. Alright, but you can ask now, if we need to have a good utilization factor, what are the factors which affect it to have a good utilization factor? Here the first factor is the painting color in the room, as the painting color affects the reflection of the light in the room. And this is because when the light is falling out of the luminaire, it falls on the ceiling of the room, and it falls on its walls also and on the ground of the room. And when this light falls on the room, it's absorbed by the room walls, ceiling, and the ground of the room, and it's reflected from them again. And this reflection of the light has an index which specifies the degree of the reflection of the light. And this means that the more reflection of the light, the higher reflection index, and the lower reflection of the light, the lower reflection index. And because the ceiling is the nearest object to the light source, so we will find that the reflection index of the ceiling to be the highest, then the walls have a lower value of reflection index of the light, because it's the second object that the light can fall on. And finally, the ground or the floor has the lowest reflection index, as it's the farthest object from the light source. So if we refer to the reflection index by row, we will find that row ceiling is larger than row wall, and it's larger than row floor. Hence, what we wanted to say is that once we get farther from the lighting source, the reflection index becomes lower, and for that reason, the ceiling reflection is larger than the wall's reflection, and the wall's reflection is larger than the floor reflection. Alright. But this reflection of the light rays depends also on the color that the light falls on, and this means that when the room has light colors, its reflection index will be small, and this is because the light colors reflects the color greatly, or it doesn't absorb the light. For example, if the room we are working on has white color, as the white color is very light, so it's not absorbed by the light rays, hence the light will not be reflected from the walls and the ceiling, so its reflection index will be very large. And the opposite is right, as if we are working on a lighting design for dark room or a room which has dark colors, like the brown color for example, as dark colors absorb the light rays, so the brown color will absorb the light rays, hence it reflects less color rays, and in that case we will have a lower reflection index. Alright, but the important question now is that, how can we select the room reflection index, as the utilization factor depends on the reflection index? In that case, to select the reflection index we have two methods. The first one is to select the color of the room, and this needs to have the colors of the room previously before making the lighting design. So the room colors are decided before making the lighting design, or this piece of information is given. Here suppose we have that room, here its ceiling color is gray, and its walls color is gray also, and finally its floor color is black. In that case, by entering the object's colors and the program we are making the design at which, at that case we are assigning the reflection index of each wall of them or each object of them by entering the color directly. But suppose we have another case at which we don't know what are the colors of the room. Here at that case we need to enter the reflection index of the room directly, and at that case we assign the ceiling reflection index with a value which ranges from 0.7 till 0.75, and for the walls reflection index we enter it with 0.5, and finally for the floor reflection index we enter it to P from 0.2 till 0.3. And we put those values assuming that the room color will be white or a nearer color to the white. So that's for the room painting, which is the first factor affecting the utilization factor. More than great. So that's about this tutorial at which we continued explaining the manual designing steps, and on the next tutorial we will continue illustrating this topic. Hope that's it right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will continue learning about the lighting systems and its manual designing steps. So fasten your belt and let's get started. The aim of this tutorial is to continue learning how to design the lighting system, so we need to know what are the different steps of designing the lighting system, as we will start constructing the lighting systems using the manual calculations. So let's go ahead. If you remember, on the previous tutorial we ended with the first factor which affects the utilization factor, and now the second parameter which affects the utilization factor is the room index, and the room index is an index which depends on the dimensions of the room, and we refer to it by the sample K. And this means according to the dimensions of the room, its length, width and height, we specify the room index. So if this is the room which need to make the lighting system for, here we find its length to be this dimension and its width to be this dimension, and this will be the height of the room. So according to those dimensions we can calculate the room index K. But the important note here is that the height of the room starts from the lighting source until the working plane on the room, and the working plane is the object that we need the light to fall on. So in our case here the working plane is this table, as we need to focus on this table to illuminate it. So what we wanted to say is that the height of the room is not the total height of the ceiling starting from the ceiling to the floor, but it depends on the working plane and its position starting from the ceiling of the room. And on the other hand, the working plane itself is the height of the object which we need to illuminate. So in that case here, the working plane equals the table height. And to calculate the room index, it's calculated from this equation. Here it's equal the room length times the room width over the room length plus the room width times the room height. So by this formula we can calculate the room index K. But also for the working plane it has no fixed length, as it depends on the nature of the room. For example, if we are designing the lighting system for a kid's room, as the kids plays on the ground, so the working plane at that case will be the floor of the room, as the floor of the room is the object which we need to focus on, so we need the lighting system to illuminate the floor of the room. And at that case the working plane will be 0, hence the height will be the total height of the room starting from the ceiling till the floor of the room. And the same thing if we are designing the lighting system for the corridor, as at that case the working plane will be 0. This is because the height will be the total height starting from the floor to the ceiling of the corridor. Very good. Also, we have another example if we are designing the lighting system for a bedroom. At that case, we need the lumens to reach the bed, and the working plane at that case will equal the height of the bed, while the height will be the distance starting from the luminaire to the surface of the bed. So the ceiling height will be the height plus the working plane. But The working plane is not the only parameter we need to take into account when making the lighting design, as the lighting design depends on another parameter which is called the wall zone, and the wall zone is the offset distance that the furniture goes further from the wall of the room walls. For example, if this is the room area, we will have a distance that the furniture goes further from the walls of the room. So if the furniture lays inside this orange rectangle, we will have an offset distance from the walls of the room, which is called the wall zone. And as we said, the wall zone is related to the wall furnishing or the furniture position inside the room. This is because the room furniture lays further from the room walls. For example, for the corridor lighting system design, the wall zone will equal 0. This is because there is no furniture in the corridor, so there is no offset distance. Alright. Also, another example is the meeting room, as at the meeting room there is a meeting table which has an offset distance from the walls of the room, hence the wall zone is considered to be 0.5 at that case. So we will have here a wall zone of 0.5 meter. And also for the bedroom, we consider having a wall zone as the bed doesn't lay beside the wall directly, but there is an offset from the right and left of the bed. And for that reason, we consider the wall zone at that case to be 0.5 meter. Very good. Now the final parameter affecting the utilization factor is the space to height ratio, or S over H, as here H is the height exactly as we learned it, starting from the lighting source to the working plane, and then the space or S is the distance from one luminaire to the adjacent luminaire. So for calculating the utilization factor, we take into account the space to height ratio, or S over H. And this ratio can be greater than 1, so it's a percentage which may be less than 1 or greater than 1. And for its accepted value, it should be in range of 0.8 till 1.2, so it shouldn't be less than 0.8, and it shouldn't be larger than 1.2. This is to have a good lighting system design, or to have a lighting system design that have a good utilization factor. Very good. So that's for the parameters affecting the utilization factor. But you can ask now, how can we select the final value of the utilization factor in the practical design? Here we say that if we are making the lighting design using the software or a kind of programs, we will enter the previous parameters which we illustrated before, which are related to UF, like the space to height ratio, the wall zone, and the working plane, and also the colors of the room. But suppose now we are making the design manually, so how can we select the utilization factor? Here at that case, we enter the utilization factor to be 0.5, as 0.5 is a more practical value that we are making the design according to it, so it's suitable for most of cases. And at that case, we are supposing the worst case to have the sufficient lighting system design, which have sufficient number of luminaires, which produces the sufficient number of lumens for illuminating the room we have. Alright, so by that way we can hack all the parameters required for calculating the number of luminaires required for any place. This is to make the manual lighting system design. More than great. So that's about this tutorial at which we continued explaining the manual lighting system designing steps. Hope that's it right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. Very happy that we are all together again. In this tutorial we will continue learning about the lighting systems and their manual designing steps. So fasten your belt and let's get started. The aim of this tutorial is to discuss the different types of spreading the luminaires on the space we are working on. So we need to know how the luminaires can be spread. So let's go ahead. If you remember, in the previous tutorial we ended with calculating the required number of luminaires, as we have analyzed all the factors which the number of luminaires depend on. And now after selecting the number of luminaires, we need to know how those luminaires can be inserted on the room ceiling. And for that purpose, we have more than one method, as the first method of distribution is the field or the matrix method, as at that method we insert the luminaires on a shape of matrix, and because the matrix is described by the number of columns and rows, we will find that we have a number of columns multiplied by a number of rows. For example, if we have those 6 luminaires, the matrix can be 3 times 2, where we have 3 columns and each column of them has 2 luminaires, so we have 2 rows and we have 3 columns. And this method of distributing the luminaires or spreading them is called also the field, as the luminaires are distributed also in a shape of field. And we are using this matrix method of distribution in the larger places, or on the places that we need large number of luminaires at which, as the field distribution method will be a good one for spreading the large number of luminaires. And the larger places are some places like the airports, as you see here, as the airports have large halls, so we need to spread large number of luminaires on the airport hall, hence the field method will be a good one. And also for the conference room, for example, the matrix method will be a suitable one, as we have a large area for the conference room which we need to illuminate, so we spread a larger number of luminaires using the matrix method. And by the same way, we have some other applications like the mall hall, as we need a larger number of luminaires to get a suitable lighting design for the larger places like the mall hall. So this is the use of the matrix method, and we use it also for the places where the aesthetic form is required, as the field shape is not the aesthetic one, but our aim here is to get the required amount of lights to illuminate the place. And for that reason, we use the field method also in the offices where a formal shape of distribution is required. So here the formal shape is required, not the aesthetic one. Very good. Now the second method of distribution is the line method, as at that case the luminaires are distributed in only one line or one row, and we use this method of distribution in the narrow places which have narrow width, and this is like the corridor, for example. Although the corridor is a long one, but it has a narrow width, hence the line method will be a good one. Alright. Also, the third method of distribution is the circular method or the curvature method, and at that method of distribution we will find the luminaires to be distributed in a full circle shape or a half circular shape, for example, or the luminaires can be also distributed in a curvature shape to take a shape of curve. And we use this method in the applications at which the decorative shape is required, as the decorative shape has an aesthetic form, so we need this method in those applications where the aesthetic form is required. Alright. Now the final method of distribution we have is the individual method, and at that case the luminaires are distributed individually, so we have no specific shape of distribution, but we insert the luminaires one by one in some positions which we specify, like this figure. As you see, there is no specific method for distributing the luminaires, or there is no uniform shape of distribution. So if there is no uniform shape of distribution, this is called the individual method. And as we said, this method is used if we decided the position of the luminaire manually one by one. More than great. So let's pause this tutorial at which we illustrated the different methods of the luminaires distribution. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial we will continue learning about the lighting systems and its manual designing steps. So fasten your belt and let's get started. The aim of this tutorial is to discuss an example to apply on the manual lighting system design, so we need to know how the lighting system can be designed manually by a practical example. So let's go ahead. Now we need to design a suitable lighting system for a computer room. So we have a computer room which we need to illuminate, and we have some following data. Here the room length is 6 meters and its width is 4 meters. And for the ceiling height, it's 4 meters from the floor of the room. So the total height of the computer room is 4 meters. But the luminaires are not installed directly on the main concrete ceiling of the room, as we have a suspended ceiling which lays on a length of 0.75 meter from the main ceiling. So the suspended ceiling goes down from the main ceiling on a length of 0.75 meter. So those are the required dimensions of the room. Then for the lighting design data, we suppose the light loss factor to be 0.8. As we said before, 0.8 is a practical value of the light loss factor, hence we will use it. Also for the utilization factor, we set it to be 0.5 as we use this value of 0.5 for the manual designs. And then for the used luminaire, we will use a Philips luminaire which has this code. So this is the code of the used luminaire, and we can download the datasheet of the luminaire and extract the required data from it. Very good. Now those are the givens of our example, but we need to convert those givens to real data which we will use in our calculations to detect the required number of luminaires. Here the first piece of information is the type of the room, as we are working on a computer room, hence we will enter the international code for detecting the required amount of lux of this room. And here from the code we will find that the computer room needs 500 lux. So we will substitute in the number of luminaires equation with 500 instead of E or instead of E average. Alright. Now the second piece of information is the dimensions of the room, as the room length is 6 meter and its width is 4 meter. So we can calculate the room area easily to be 6 times 4, which is 24 meters squared. Hence we will substitute in the luminaires equation with 24 instead of the area to get the total number of luminaires. Very good. After that, for the height of the room, we knew that the total height of the room is 4 meters, but we have a suspended ceiling on about 0.75 meter from the main concrete ceiling. Hence, the height of the suspended ceiling will be 4 minus 0.75, which is 3.25 meter. Very good. After that, for the luminaire which we will use, if we search it for that code, we will detect its datasheet to find that this is a LED luminaire and those are the information of it, or this is a piece of the datasheet of this luminaire. Here its manufacturing company is Philips. But the important piece of information for us now is the lumens out of this luminaire, as it's 3400 lumens. Here we can detect it easily from the datasheet. So in that way we have detected all the required data to calculate the number of luminaires. Here we detected the lux, the illumination, the LLF, and finally UF. And we are ready now to calculate the total number of luminaires required. Now we can substitute in the final equation to detect N. So the total number of luminaires now will be, or it will equal 500 lux times 6 meter for the length times 4 meter for the width over 3400 lumens times 0.8, which is the light loss factor, times 0.5, which is the utilization factor. And finally, we will have a total number of luminaires of 8.8 luminaire. So we need finally 8.8 luminaires to detect the required number of lux. But as the number of luminaires must be an integer one, not a float one, so we need to select the number of luminaires to be 8 luminaire or 9 luminaires. And here we say that 8 luminaires will be a wrong selection, as this is the lowest number, so it will give us a lower amount of luminaires than the required. While for the 9 luminaires it's a right selection, as it will give us the larger amount of lumens, so this is what we need to have a sufficient amount of lumens for us to be in the safe side for our design. So it's not a problem to have a larger amount of lumens a little bit, But it will be a problem to have a lower amount of lumens, hence we select usually the larger number, not the lower number, to expect the worst case at which we need the larger output value. Very good. So that's for the first step, to select the required number of luminaires. Now the second step is to decide the method of distributing those luminaires. As we said on the previous tutorial, we have the matrix method, the line method, and the circular method, and the individual method. But for our case here, as we have a computer room, so we need a formal shape of the luminaires, hence the matrix method will be a suitable one for a uniform and formal shape of distribution that will be suitable for the computer lab which we are working on, or the computer room. And because the number of luminaires we have is 9 luminaires, so the matrix will be 3 times 3. And this means we have 3 columns and 3 rows. And we have 3 luminaires across the length of the room, and we have 3 luminaires across the width of the room. But we need to know now how can we select the matrix number of rows and number of columns, or we need to know the rule according to it we select the number of luminaires across the length of the room and the number of luminaires across the width of the room. Here at this example we made it to be 3 times 3. This is because there are 9 luminaires, so there is no way to have another distribution strategy instead of this one, as the number 9 is only the multiplication of 3 times 3. And now to know how to select the matrix row and column, we can suppose the number of luminaires we have got as 12 luminaires instead of 9. Here this is an assumption to clarify the concept we need to illustrate. So if we suppose we have 12 luminaires, they can be distributed in 2 ways. The first way is 4 times 3, and the second way is 6 times 2. But we need to know which one is the correct or the most suitable and which one is the incorrect. And to do so, we need to get firstly the ratio of the room length to the room width, so it will be 6 over 4, as 6 is the length of the room and 4 is the width of the room. So the ratio will be 6 over 4, which gives us 1.5. Now we will get the ratio between the number of columns to the number of rows, and now we will get the ratio between the number of columns to the number of rows at each case of them, or at each method of distribution. And at the first case we will find that we have 4 over 3, which gives us 1.3. And for the second case we will find that we have 6 over 2, which is 3. And now the next step is to compare each ratio which we have got in the 2 cases by the ratio of the length over the width. So in the first case we will find that 1.3, which is the first distribution ratio, is very near to 1.5, which is the length to the width ratio, while the second distribution ratio is 3, which is very higher than 1.5. And for that reason, the accepted distribution strategy will be the first one, which is 4 times 3, as it's the most nearest ratio to the length over the width, while the second one will be a wrong distribution strategy, as 3 is very larger than 1.5. Very good. Now let's go back to our original example where we have 3 times 3 luminaires. And at that point, after selecting the number of rows and columns, the next step is to decide where will be the positions of the luminaires. And to decide the positions of the luminaires, we have 2 rules that we follow to get the luminaire's position. The first rule says that we have equal distance between each 2 luminaires, so the distance between each 2 adjacent luminaires is the same. For example, if the distance between the first luminaire and the second one is s, at that case the distance between the second luminaire and the third one will be s also. So that's the first rule. Now the second rule says that the distance between each luminaire and the other equals 2 times the distance between the luminaire and the wall. For example, if the distance between the luminaire and the other equal s, and the distance between the luminaire and the wall equals y, at that case s equal 2 times y. Alright, now we need to apply those two rules on our example to know what will be the distance between each two luminaires and what will be the distance between the luminaire and the wall. So for the room length, we will find that we have 3 luminaires, and the summation of the distance between the luminaires and the other and the luminaires and the wall will be s plus y plus y. But as s equals 2y, so it will be y plus 2y plus 2y plus 2y, and it's equals 6 meters, which is the room length. And when solving this equation, we will find that y equal 1 meter. And this means that the distance between the room wall and the luminaire will equal 1 meter, while the distance between each luminaire and the other equals s or 2y, which equals 2 meter. So that's for the luminaire position across the room length. Now for the luminaire position across the room width, we can suppose that the distance between each luminaire and the other equals 2x, while the distance between the luminaire and the wall equals only x. And at that case, the equation will be x plus 2x plus 2x plus x. So this means that we need a distance between each luminaire and the other, which equals 2 times 0.6, which equals 1.2 meter. And this means that we need a distance between each luminaire and the other, which equals 0.6 times 2, which equals 1.2 meter, while we need a distance between the luminaire and the other of 0.6 meter. Very good. So this will be the final design of the luminaires which we have. As you see, the distance between the luminaire and the wall is 1 meter, then the distance between the luminaire and the other is 2 meter. This is for the length. While for the width, the distance between the luminaire and the wall equals 0.6 meter, while the distance between each two adjacent luminaires equals about 1.2 meter or 1.3 meter. More than great. So that's about this tutorial at which we illustrated a practical manual example on the interior lighting system design. Hope that's clear right now. Thank you for watching and see you next tutorials.